Hi guys, this is Miss Rapp. We are on Unit 6 Polynomials, and this is going to be Lesson 9, Rational Root Theorem. Let's get started. Okay, so I'm sure all your teachers have been talking about that Unit 6 is kind of where things start to get real with the math, and this lesson is no excuse. So we're learning about a new theorem today, the rational root theorem. So let's take a moment to read this. The rational root theorem, given a polynomial with integer whole number coefficients, the possible solutions roots are found by dividing each factor of the constant term by each factor of the leading coefficient. So that's a lot of math talk, but basically it's saying I can find a list of potential x-intercepts by dividing the leading coefficient by the constant term. Okay, so I'll talk about what this means. So if I had this polynomial, my leading coefficient is 10 and my constant is 12. So you list the factors of 10 and 12, and then you do P over Q. So you'll put the constant term factors divided by the leading coefficient factors. So this is Q and that's P. Why is this useful? If we're not provided a factor, we don't need one. We can just use the rational root theorem. So some people call this RRT, rational root theorem. So you'll see your teacher saying, oh, use RRT to figure this out. So hold on tight, we are going into this. What are the possible solutions of these polynomials? So this won't be a final answer, this will be getting us there. So I would say that P equals -8 and Q equals 3. So that's P and that's Q. So the factors of my constant, so my factors of 8 are positive and -1, positive and -8, 4 and 2. All these numbers can multiply to 8. My leading coefficient factors, well, 3 is prime, so it's just plus or minus 3 and 1. So this is 4 numbers because it's positive 3, -3, positive 1, and -1. So then my possible solutions, you literally are going to do P over Q. So I'm going to say plus or minus 1 over 3, because this is P and that's Q. 8 over 3. 4 over 3. 2 over 3. So I addressed all my denominators of 3. And now I'm going to address my denominators of 1. 1 over 1. 8 over 1. 4 over 1. And 2. So there's 1, 2, 3, 4, 5, 6, 7, 8. 8 times 2 is 16 because positives and negatives. So there's 16 possible answers. And that's it. They asked what are the possible solutions. So out of all of these, all of my answers lay in here. And I'll show you guys how to check those later. So let's do this one. So this is P and that's Q. So my constant factors are plus or minus 5 and 1 because 5 is prime. And then my leading coefficient factors are going to be plus or minus 2 and 1 because those are the factors of 2. My P over Q is going to be plus or minus 5 over 2, 1 over 2, 5, and 1. Okay, so this was P, that was Q. Some of you might be just like, what just happened? So this is a strategy that's going to help us figure out big problems, and we'll go over those. So it says, when subbing in the possible solution to the polynomial, the answer should be 0. If this is the case, then the solution works. Okay, which possible solutions work for 2x cubed minus x squared plus 2x plus 5? So I just took this problem and I took my numbers right here and I put them on a table. So 1, -1, 5, -5, 1/2, -1/2, 5/2. So all of these numbers are on this list. Okay. Here's what we're going to do. I'm going to show you guys how to do a really cool trick with your calculator. If you don't have a graphing calculator, you can do this by hand or use like an online tool to make a table. So here, I'll do it by hand first. So I'm going to plug in 1 for x to this. And if I get 0, then it's an answer. So let's check. 2 times 1 to the power of 3 minus 1 squared plus 2 times 1 plus 5. So I got 8. So that means that 1 is not an answer. When I get 0, then I know it is. Okay, but going through and doing all that work is annoying. So I'm going to show you guys a trick on a graphing calculator. So you press y equals, and you're going to type in the function. We haven't done a lot with graphing calculators this year. Usually we do more because I can bring them to you, but obviously we're in a pandemic. That's not the case. So you type it all in there. You press second graph. And now you have a table. But before you get here, you're going to do second window and make sure your settings match mine. It should say independent ask. So I pressed second window and I got to this screen. So I want to put independent on ask. So now I'm going to go back to the table. And now I can plug in all the x values. So if I write -1 and press down, it plugs it in for me. So there's a 0. 5. That was 240. -5, that was -280. 0.5 got me 6. -0.5 got me 3.5. And I'll go over this in class as well. 5/2 got me 35. And then -5/2 got me -37.5. Right here, that is the money. This means x plus 1 is a factor and -1, 0 is an x-intercept. This is a really powerful tool because until now we had to factor and graph and solve, but now we just do the rational root theorem and we get all of our answers. Okay, let's move on. Remember, guys, highlight and write down any questions you have. Okay, so putting it all together. Identify all possible solutions or roots of the polynomial. So, looking at our polynomial, so basically I can ask a question that says like graph this by hand. And to graph it, you're going to have to do a few strategies, and rational root theorem is going to be one of them. So let's just go in order. Identify all possible solutions. So this is going to be the rational root theorem. When it says possible, you know it's talking about that. So this is P and this is Q. The factors of P are plus or minus 6, 1, 3, 2. Factors of Q, plus or minus 1 and 2. So P over Q is going to be plus or minus 6/1, 6/2. One over 1, 1/2, 3/1, 3/2, 2/1, 2/2. But let's look at our list. So 6 is fine. 6/2 is 3. That's 1, 1/2. We already have 3. We don't need it again. We don't have 3/2. We need 2. But we already have 2/2 being 1, so we don't want to repeat. So this is our list. Okay, so now it says confirm one of these roots. So it's saying grab your calculator and start plugging these in. So guys, here's a trick. I always start at 1 and -1, and then I'll go to like 2, -2. but it should be either 1 or -1 with the ones that we give you. So let's try -1 to start. So I'll do this. I'll just do this like not with my table, just in case you don't have a graphing calculator. And if you don't have a graphing calculator, do not worry, you guys. You got this. And we can do apps, whatever. So I'm going to plug in -1 to my function. So f of -1 is going to be so let's do that. 2 times -1 cubed plus -1 squared minus 7 times -1 minus 6. 0. That's a good sign. Okay. So that means that x plus 1 is a factor. So now it says, so use the confirmed root and division. Find a polynomial that would multiply with your confirmed root to use our original function. So here, I'm going to use synthetic division. So I'm going to put -1 in the box, and I'm going to list out my coefficients. That was a -6, yeah. If you are like, what is she doing right now? You need to look at the last lesson, okay? So I'm doing synthetic division. 2 times -1 is -2. 1 combined with -2 is going to be -1. -1 times -1 is +1. -7 plus 1 is -6. -6 times -1 is 6. And you better get no remainder here, because if, like, you have to get no remainder here because we already confirmed it's a factor. So now I can say, oh, well, x plus 1 and 2x squared minus x minus 6 is a factored form of this. That's our confirmed root. Okay, guys, do not forget to pause. Please. I don't have long pauses in here because I want this video to be as compact as possible. So pause me. Pause me. Factor the remaining polynomial and find all solutions. So I have 2x squared minus x minus 6. I'm trying to multiply to -12 and add to -1, 4 and 3, I believe. Yes. Four is negative. So I draw the box. So once again, everything builds. We had a factoring lesson. Now we're factoring to help us. So if you were shaky on factoring, you got to feel good about it because it comes up again. So from here, I could take out a 2x, x, -2, and a 3. So I now have x plus 1, 2x plus 3, x minus 2. So I know x equals -1 is an intercept, multiplicity 1. X equals -3/2 is an intercept, multiplicity 1. X equals 2 is an intercept, multiplicity 1. Okay. Now it's really going to come together. It just says graph it. So I can just ask you, graph this, and this is all the work you would do, but I'm not going to talk you through it. This is just an example. Okay, so when we graph, I'm just going to write the original problem right here. It is 2x3 plus x squared minus 7x minus 6. My degree is odd. My leading coefficient is positive. Odd positive is going to be down, up. My y-intercept is 0, -6. If this is confusing, you need to go back to lesson 6. Okay, so step 1, I'm going to plot all my intercepts. So I know I'm going to have a dot on -6. I know I'm gonna have a dot on -1. -3/2 will be really close. And then +2. I know I'm down, up. All my multiplicities are 1. So these are all gonna be pass through. Pass, pass, pass. So I'm gonna go, so sometimes I sketch it lightly. So I'm gonna go up, through, up, down, up. So pass, pass, pass. And there you go. Look, mine's not even perfect, you guys. Remember, I'm looking for correct intercepts, correct end behavior, correct multiplicity behavior. Okay, everyone, that is it. I know it's confusing. I know it's long, but you have to give yourself the opportunity to learn it. So don't just give up right away. Please go do your video check-in. Have a great day.